Hello everyone, welcome to Conf42 Golang. In this talk, you'll learn how to secure Go APIs with decentralized identity tokens. My name is Mohammad Shahbaz Alam, a developer advocate at Magic, an authentication-based company which will help you with all your authentication and authorization needs. So in this talk, we will learn how the user trust model of the internet is broken, what is decentralized identity token, and we will learn auth at Magic. We will also see what is authentication, authorization, and also see how to build a Go API. And then later on, go on to secure that Go API with Magic. So let's get started. Users think of secrets or password very specific to them to verify identity and often hand them off to apps owned by various companies. 59% of all users reuse their passwords across apps. I'm pretty sure someone in the audience have used same password for multiple applications. Users entrust companies to store their secrets securely and responsibly, but many companies roll their own authentication without the prior knowledge of security at all. Users access the company's services by showing the secret again and again to the developer. And every time that secret is shown, there is a risk of exposing it to the hackers. Consider this step as similar to writing your secret in a piece of paper and giving it to the application developer. Companies might get hacked and lose secrets along with users' trust. 48% of customers never come back after a breach. The Equifax breach has cost them at least $1.4 billion. The hackers use stolen secrets to impersonate users to access their vital online services. They use the same stolen password at multiple applications because of password reuse. And this problem compounds now that there are many companies acting on behalf of users to authenticate for them. And the user's identity is no longer in their own hands, but controlled by a handful of large corporations. So what people tried before Magic? They came up with zero-knowledge authentication, a key-based model. Instead of users thinking of secret themselves, they will use the blockchain-based public-private key pairs, which are randomly generated to access applications. It has its pros and cons. The pros were users have complete control of their identity, which is good. Companies can't know users' secret, again, more secure and good. Users can use the same secret to access application, which is a cleaner trust model where there are no identity silos by companies. But it has its cons. Users are likely to lose their keys. I'm sure many of you have forget your password, and we do too, which will lock them out of use good and lose their online identity, or worse, get them stolen. So concept of using a key on the internet is too unfamiliar for mainstream users because of bad UX. And how Magic improves the trust so far? Magic uses a delegated key management model which leverages large infrastructure as a service and secure user keys with hardware security modules. Consider hardware security modules are similar to your YubiKeys, which are a hardware device used as a second factor authentication to store your private keys. Consider these hardware security modules on the cloud with technology. Magic leverages these with technology that hides and protects users' private keys from companies and even from Magic. It brought additional pros, which are Magic provides familiar passwordless auth UX, like email passwordless, email Magic link, social logins, WebAuthn to users for them to retrieve their keys, which is a better UX, and they can no longer lose their keys. Magic doesn't store passwords and cannot know users' keys or secret, which is a more security and it provides more trust. Magic has native support for multiple blockchains, and it has only one con, which is that it is reliance on single infrastructure as a service. So the question is, what is DID token? DID token created by Magic is adapted by prior techs like JWT, which is JSON Web Token, and W3C's DID protocol. It is encoded as a base64 JSON string tuple representing proof and claim. It leverages the Ethereum blockchain and elliptic curve cryptography to generate verifiable proofs of identity and authorization. These proofs are encoded in a lightweight digital signature, which is shared between client and server to manage permissions, protect routes and resources, or authenticate users. Decentralized Identity Token looks similar to this, which it has its proof and claim. The claims are the data representing the user's access. It has user's information, and the proof is a signed data with Ethereum's personal sign method. And we get proof out of the claim. And then we encode this proof and claim, and by that we get a DID token. And generating a DID token, this is how a pseudo code look like. It has a claim representing the user's data. The issuer used here is the user's public address. And again, that claim is signed by Ethereum's personal sign method. The claim has issued at expiration, subject, not valid before time, and bunch of other informations. And this again, this encodes the DID token. We encode the DID token so it can be transported over HTTP. The decentralized ID token specification can be found on docs at Magic Docs, and visit the decentralized ID section, where you will get more understanding of what each key does. This is how you generate a DID token with Magic. This is a JS implementation of it. You can do it in Android, iOS, and React native applications as well. And this is how you get a DID token at client side. So first we import the Magic SDK, and then we instantiate that Magic with API key. And this is an API key which you get on signing up to a Magic account. We will see later in this talk. And then once you do with the 2 line of code above, the third one is to use the auth module of Magic SDK and call a function called login with Magic link and pass on the user's email address. And once that is done, the user will be able to log in with a Magic email, a Magic link on their email. By default, this function also gives you a DID token. If you store it in a constant called DID token, it will give you a by default DID token with a lifespan of 15 minutes. But if you want to extend the lifespan of a DID token, consider the lifespan as a validity of your token. And you can use the user module of SDK and call the getID token, and again pass on the lifespan, and this lifespan is in seconds. If you want more than 15 minutes, pass on more than 900 seconds. And to learn more about it, you can visit the decentralized Magic doc to see how you can generate a DID token with Magic. So understand what is authentication and what is authorization, and then we will see how we do it, how we differentiate here at Magic and how it works. So authentication is something, are you the one who you say you are? And if your answer is yes, this is what authentication does. And authorization is something like, are you allowed to do this action? So if your answer is yes, because you are allowed to do it, these are called authorization. Do you have the permissions to access that particular resource or route? And in this talk, we will see both of it, how to get how to authenticate and then authorization. So once you log into Magic dashboard after signing up, you will see something like this, your first app. And we use the API key in the client side, and we use the secret key at the server side. We will see in action how that happens in Go APIs. So authentication, the login with Magic link flow, how Magic link get generated, how the authentication is handled here at Magic. So consider a login request comes from your browser app which has a Magic SDK loaded. The Magic iframe loaded onto your application. Iframe is loaded into your application, and a login request is made to Magic service. And once that is done, there is a poller going on, which checks every 2 seconds whether the login has been done or not. And that has been passed to Magic Services. Magic Services send a magic link email to your to user's inbox. User opens that email, click on the confirm link, and the login is done. And at that time, the poller gets resolved, and it says that the login has been done, and it resolves the SDK promise. Optionally, you can have a browser app, a different context. You can redirect to different URL. And once you have the authentication, for example, user has the browser, it using the client application, the login, and they get a DID token in return. In that DID token, there is a bunch of information about users. We pass that DID token in the authorization header when we call the server at a protected route. And when we want to protect a route, we would encapsulate that function, that route inside a protected method. We will see how that looks, and then we try to access that API route by passing the DID token in a authorization header. At the server, we extract the DID token from the header. We validate that token using Magic SDK, and once that is done, the DID token is valid token. We say that go on and see, because you have the permissions, you have a valid token to access the resources. So let us see how to build Go API and how it looks. This is a simple Go API main.go file, which has under normal stuff, but I have used Gorilla Mux over here to handle most of our routing. And so what it has, we have a bunch of imports, and then we have handle request function, which handles most of the things. And then we have home page, which returns a response, welcome to home page, as you can see here, and the server is running. And then we have a protected page, which says, which is right now it's not protected, but it's accessible without the token. But the ideal goal is to protect this particular route with a DID token. And then we have something called myrouter.handle function, and this is how we have a main route, the home route, and we call a function over here, which is a home page, and then we have a protected route calling the protected function. So if you try to run this, you will see multiple things, and we are using port 9000. So this is how you listen and serve. So this is a very normal Go API. The idea is to just simulate and see how we protect a normal API of Go. So the server is running on localhost 9000, and then when you try to see a protected route, it says that you are seeing a protected page without the token. So just so that we don't have to worry about how things happen here, I will go ahead and convert this particular application into a protected application and see how it looks. So this is what you will see, what I have added, multiple things, and I'll explain one by one. So this is the same function, a same API, which has welcome to home page. But when you try to access the protected page, it says that the bearer token is required to access this route. So this token is what we will be working on, how to get that token, how to verify that token, and everything around that token. So, and here the token is the decentralized identity token, right? So we are using something called .env to process and load the environment variable from .env, and we are using something called magic secret key. As I said, at the server side, you use the magic secret key, and at the client side, you will use the magic API key, right? So apart from this, the Gorilla Mux, which is same, and I have just added .env to access and load the .env variable so that we can use the magic secret keys, right? And apart from that, I have used a constant called auth bearer with bearer. And here we have imported this magic admin go from Magic Labs. So we'll see how you could do that, and that's it. So after getting the secret key, magic secret key to a variable, we instantiate the magic SDK calling client.new and then passing on the secret, and this is how we instantiate a magic SDK. And then what we check is we check a bearer token. So we first define a function so which will act as act as a middleware, right? Middleware to a protected route. So what it does is that it first checks whether the DID exists in HTTP header or not. This is how we extract a authorization header, and we compare that it has the prefix of bearer, what we have defined here. And once the bearer token is present, we pass on. If not, we say that bearer token is required to access this route, and we will see everything in action when we'll do the demo. And then once we have a bearer token in the authorization header, we go on to extract that bearer token from the authorization header, and that is what we have, which is a DID token passed on from the client side. And then we create a token instance to interact with the DID token, and this is how we do it. You can check more about this in the docs later on. And we check here is whether the DID token is malformed or not. If there is an error, it will throw out that particular error. At this stage, everything is fine, and this is what we do at server side. Every DID token must be validated at server side, so you are working with a valid DID token. And this is how you do validate. A token validate at Go server. And if there is a token failed validation, it will throw that error. And apart from that, you can simply pass on the you can step ahead with next with resolve with request and response. Right, but this is what you can get more information about that DID token, what it contains. So Magic SDK is how we instantiate here the magic, and then we call the user module of Go SDK, and we call a function called get metadata by token. Here the token is DID token. We pass on that, and we get all those user info. So user info has email, issuer, and public address. We will see in action how it looks. So, and once that is done, the next function will go on to continue with the response and request. So this is how we define a check bearer token middleware, which checks the bearer token as well as validate the token and extract the user info from magic function called get metadata by token, right? And this is what the handle request is. It's similar to the previous one. As you can see, this is same. What we added here is we wrap the protected page function inside check bearer token middleware. So this is how you protect your you protect your route. And nothing fancy over here. It's as simple as the previous one. And we have a home page function which just says welcome to home page, and a protected page which says you have access to see protected page. But when you try to see it inside a browser, it says bearer token is required. And to access this particular route, you would need access to bearer token, right? Or specifically the DID token. So how do you get a DID token and how to use that? So this is a front end of the application. You can generate front end from multiple templates. I have used Next. What you would do is just run npx and make magic. We will see how it looks. And this is how you get a DID token similar to this. So what has happened, similar to what I was saying, how you do the auth.login with magic link and pass on the email, right? And additionally, you can create a DID token calling the user module and calling the function get ID token and passing on the lifespan. Here, the lifespan of the DID token is 8 hours. Consider this as a second, the second, minutes, and hours. So this is equivalent to 8 hours. Right, and so we get a DID token. You can see how it looks. The front end of the code is hosted on GitHub under a repo called frontend Go API. You can check out later on. So this is how you get a DID token, and simply you can clone. There will be steps to get functions, but when you clone this, you just need to to replace these variables, right? The publishable API key and the secret key. Secret key can also be used at server side, at the client side as well, but here it is used inside a next application which has something called API, and you protect you pass on and you protect multiple things. So let's not go into that, but which is beyond the scope of this video. So, and talk. So let's grab this DID token, and once you do that, you will be able to get a DID token by logging into your application, providing your email address. Email will come to your email ID. You just need to open that, click on that, you will be able to log in. If not, you will see a multiple demo on Magic YouTube channel. So grab that DID token which you get, which has a lifespan of 8 hours. Copy this and try to access the protected route. Right, this is hosted on localhost 9009. The other one is hosted on 9000, which is not protected, but let's see, because we have added DID token and verify functions in this Go APIs. When you try to access normal one, it's same, like welcome to home page. And when you try to access the protected route, again, it will have the same result, like bearer token is required to access this route. So how do you access that? This is what I'm using. This is Postman. You can use Insomnia and any other tool just to test and see, but usually you will do normal fetch from the front end of your application, or maybe you will use Axios to access these kind of information and pass as an authorization header from there. So passing the select the authorization here, and from the drop down select the bearer token and pass on the DID token which I have grabbed. So I'm not going to use the previous one. Let's copy let's paste what I have copied from that application and try to access it. So when you try to access it, it gives you bunch of information, which is email. And when you decode that DID token at the server side, what we are calling is get user metadata. And we are calling that function. We are getting the metadata, which has its email, issuer, and public address. So it has these information. Apart from that, because we have a protected page which has a message that you have access to see protected page. So let me show how it looks. This is what I'm referring. So this is the protected page part, and when you do the check bearer token, and this is where we have used the user info and email, issuer, and public address to return that in the response, right? So that's really cool, and you have your application, your API protected by Magic SDK, and you are using the DID token to fetch and access those of information. So what next, and how do you get that? So visit magic.link, try for free account. By default, when you try to do it, there will be 10,000 free logins you will get. If you want more than that, there is a referral program going on. By doing that, you can get more, like 10,000 plus 90,000 free logins if you share with your friends. Once you sign up, you will be able to create an application similar by going to this, or maybe by default you will have your first application created, right? And then you can create your application and then you will have this publishable API key. Feel free to share this publishable API key, which is not but not recommended, but you can share it, but no issue with that. One thing to note is that whichever combination you're using, the front end, if the front end has this API, it should have the same secret key from the same application. Otherwise, you will get multiple bunch of errors, right? And you can also enable multiple social logins if you want to have it. Like right now, it has just the email link. You can create Google, GitHub, Facebook, and so on, even Discord. That's how you get the API key and the secret key, and that's it, right? So what next? Apart from this, I'm saying what next? There you can do multiple things. You can build a full-fledged REST API, which has its CRUD application, everything around that. So there is a guide on Magic website. Visit that. It's called Securing a Go Back Scrappy Twitter API with Magic, and you'll be able to play around and see how it looks, even run in Postman and see how a posting a tweet look, getting all information about the tweets, get a single tweet and a bunch of information. And to get a DID token and play with this particular demo, just visit this link and you'll be able to, again, similar application. You just need to sign in and you will get another DID token like this, right? And I have also used this. This is what the Scrappy API looks like, which has, the REST form of it API, which has, the CRUD application. This is how you create an application. And before creating a tweet, let's see what we have in like get all tweets. If we try to fetch this, you will see one tweet from Mary Chris, a colleague of mine, that this is our first default tweet. And if you want to create a tweet, again, this is protected route, right? And if the body has like, this is our second tweet, if we try to access it, it says that the DID token is malformed because I think there is an authorization header or something is missing, right? So let's try and add that bearer token from the link what I have just copied. And you would need to sign in and do the same process. Try to access and have this. So it says that there is a success. This is a second tweet. And as you can see, the author is my email ID, which is what I am logged into, right? I'm logged in with Shahbaz at Magic Link, and it returns that thing. And you can also see and validate from, fetching all the tweets. And similarly, if you, for example, try to delete a tweet, for example, if you try to delete the tweet, which is owned by Mary Chris in this case, and if you try to access this, it will say like something is malformed because it's missing. So let's try and again copy and paste the same DID token, try to access it. It says, oh, you cannot delete someone else's tweet because this tweet is created by Mary Chris and the second one is created by me. If I try to do this, it will like delete my tweet. So there is multiple things you can see, get a single tweet and then save user info and multiple things you can learn about. So this is a good blog post if you want to build a RESTful API and secure those API using Magic. So this is again a link which I'll share in the slides. I have used this particular section, get started with Magic. And if you want to do this, you alternatively need to either import similar to this or explicitly say go get, pass on the github.magic link /magic labs and then magic admin go. And this is how we created the instance and we created a token instance. What we have used is get metadata by token, which returns Magic user info which has issuer, email, and public address, right? You can see the examples. It has similar examples similar to what I have used, and you can use and learn more about it. So there are a bunch of resources how you do that and how you validate, how to get the issuer, public address, and so on. If you want to do the front end side of it, we have used get metadata because you can use get metadata from the front end side of it. There are things called login with Magic Link, which has multiple, the examples. It has auth modules, it has user modules. To learn anything around front end side, you would go to the Magic Docs and see the client SDK. And if you want to work with admin SDK, you will go to the admin SDK side of it. For example, because we are working with Go, you will do that in Go. So let's come back to the slides and see what we have done and recap what we did, right? So we built in Go API, and then we later on went on to secure that particular, the basic routes. And we also saw how a CRUD application looks like, how the RESTful API looks in Go API, where you can learn more about those things, right? To get started locally in seconds with Magic, you just need to run npx make magic and select from that the bunch of template. There is a bunch of templates to see. At least it has right now, it has more front-end application, but there is, I think, one server-side SDK application express APIs and Go API. If you want Go API to be here in npx make magic, do let us know on our Twitter handle or our community page. So we have used this template. This is how you define a template and get started very quickly. npx make magic and pass on the template with next. But you feel free to explore other templates as well and share your feedback. If you have any questions, do let me know on Twitter handle. This is my handle, or tag Magic Labs and let us know that as well. So these are the resources about the talk. Like the front end of the application is hosted on GitHub under a repo called frontend Go API, or like Go server is Magic Go API. You can see these things. I'll share the slide link with you as well, so you can see and learn more about these resources. And there is Magic Go Admin SDK. If you want to learn more about decentralized identity specifically to Magic, the first link would be the best place. But if you want to learn about what is DID, and learn more about the DID primer, what it is, you will go to W3C, this page. And then if you want to know what is a DID token and what it does, and again, bunch of things is on our docs, visit our docs. If you want to integrate to multiple applications and maybe use different front end, visit our guides and see how that is happening. We have a community page. You are always welcome to join us, the authentication community, where we share and learn from each other. So join that community and share your experience and what you are building with Magic. So I think that's it. If you have anything specific to me, these are the links you can connect with me, or simply as if you have a terminal and if you have Node installed, just run npx mdsvz alam, my username, and you will see similar options like this, and you will be able to follow me across social media. So once again, thank you Conf42 Golang for having me. So if you have any questions related to Go APIs, Magic, authentication, serverless, passwordless, anything around authentication, you can reach out to Magic Labs or me. I would be happy to help and answer your queries. So once again, thank you for having me, and enjoy the rest of the conference.